For decades, we've gazed into the night sky, dreaming of worlds beyond our own, sending probes like Voyager into the void to whisper our existence to the stars. But sometimes the universe whispers back, not with words, but with wanderers from the cosmic highway. Imagine a chunk of ice and rock, billions of years old, hurtling through the galaxy like a time capsule from another star system, crashing our solar system's party uninvited. That's exactly what happened this summer when astronomers spotted 3I/ATLAS, the third confirmed interstellar comet to grace our neighborhood. It's not just another frozen snowball. This one's got secrets. A bizarre backwards dust tail, a composition richer in carbon dioxide than anything we've seen up close, and clues that could rewrite what we know about how solar systems form across the galaxy. Why does it matter? Because in studying 3I/ATLAS, we're not just peeking at a comet, we're unlocking the history of the Milky Way itself, piecing together the puzzle of where we came from and what else is out there. Stick around as we dive into this interstellar intruder, from its dramatic discovery to the mind-bending data pouring in from telescopes like James Webb. By the end, you'll see why space exploration isn't about going far. It's about connecting the dots in our shared cosmic story. Let's launch into it. Picture this. It's early July 2025, and a routine scan of the southern sky from a telescope in the crisp Atacama Desert of Chile picks up a faint smudge of light. At first, it's just another blip on the radar for the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of telescopes hunting for potential Earth threateners. But this one's different. Moving too fast, too oddly, at about 137,000 miles per hour, faster than any homegrown comet should. Within days, a global frenzy erupts. Amateur stargazers and pro teams alike train their scopes on it, pulling pre-covery images from archives dating back to mid-June. By July 2nd, the Minor Planet Center slaps on the label C/2025N1, ATLAS, and then the big one, 3I, the third interstellar object ever confirmed. Fun fact, the first was Oumuamua in 2017, that weird cigar-shaped mystery that sparked alien probe theories before settling as a rocky oddball. Then came Borisov in 2019, our first clear interstellar comet. Now 3I/ATLAS steals the spotlight, arriving from the direction of Sagittarius, right near the Milky Way's bulging heart. It's like the universe decided to drop a galactic postcard right in our lap. And get this, it's already showing off with a fuzzy coma, that glowing envelope of gas and dust, hinting it's no inert rock, but a lively, sublimating beast as the sun warms it up. What seals the deal on its interstellar passport? The orbit. Most comets loop elliptically around the sun, trapped in our gravitational embrace like loyal pets. Not this one. 3I/ATLAS is on a hyperbolic joyride, eccentricity clocking in at a whopping 6.14, meaning it's slingshotting through without stopping for tea. Its speed? A blistering 61 kilometers per second relative to the sun at discovery, peaking at 68 kilometers per hour by perihelion, that closest solar hug, around October 29th, 2025, at just 1.36 astronomical units, snug inside Mars' orbit, but a safe 1.8 astronomical units from Earth. No collision worries here. It's zipping past like a bullet train on the express lane to the stars. Think of it as a refugee from another stellar neighborhood, kicked out eons ago by a rogue planet's gravity or a stellar close call. Over billions of years, it's tumbled through the galaxy's thin disk, dodging molecular clouds and star clusters until our sun's pull tugged it in for a brief detour. Retrograde 2, inclined 5 degrees to the ecliptic but orbiting backwards, a quirky signature that screams, not from around here. This path isn't just cool math, it's a window into the chaos of planet formation elsewhere. How many such ejectees are out there? Billions probably, and each one like 3I/ATLAS is a fossil from a lost world, carrying ices and dust untouched since the universe was young. Now let's get intimate with this visitor's looks and guts. Early Hubble snaps from July 21st paint a portrait. a teardrop-shaped dust cocoon hugging a nucleus no bigger than 3.5 miles across, maybe as small as half a kilometer, about 10 football fields end to end. That's puny compared to some solar system bruisers, but for an interstellar comet, it's a heavyweight, likely bulkier than Oumuamua's 400-meter sliver or Borisov's sub-kilometer core. And the colors. Reddish thanks to tholins, those irradiated organics that give it a rusty hue, like a cosmic baked potato dusted with space rust. But the real fireworks come from its outgassing, as sunlight licks its icy surface. Water vapor, carbon monoxide, and, surprise, tons of carbon dioxide bubble off at rates up to 129 kilograms per second for CO2 alone, dwarfing water's measly 6.6 kilograms per second. That's a CO2 to water ratio of 8 to 1, wildly high for something this far out. 4.5 astronomical units at discovery. Why? It likely brewed in the chilly outer reaches of its birth star, beyond the CO2 frost line, where temperatures plummeted low enough to lock that gas into solid form. JWST's near-infrared spectrograph locked on August 6th and confirmed it. Water ice grains, fine as mist, amorphous like frozen fog, plus hints of carbonyl sulfide and even nickel vapors wafting out. Imagine cracking open a galactic snow globe, except instead of glitter, it's primordial soup from another sun. This mix isn't just trivia, it's a chemistry lesson in extrasolar diversity. Our own comets lean watery and carbon poor. 3I/A TLAS flips the script, suggesting some star systems favor carbon-rich ices, maybe around cooler, metal-poor stars in the galaxy's thick disk. Here's where 3I/A TLAS gets downright weird, and I mean scientifically tantalizing weird. While most comets trail their iconic tails away from the sun, pushed by solar wind and radiation like a bad hair day in space, this one's got a rebellious streak, a backwards dust plume, pointing toward the sun like it's defying physics. Not the main anti-solar tail, that's still there, stretching up to 100,000 kilometers by September, but a fan of larger, heavier grains ejected forward by the nucleus's own jets, too beefy to be blown back. It's like a fire hose spraying confetti against the wind. The sun's heat ramps up the activity, flinging these micrometer-sized chunks ahead at 2 to 22 meters per second. And the age? Buckle up. Estimates peg it at 3 to 14 billion years old, potentially predating our 4.6 billion-year-old solar system. That's ancient, born in the Milky Way's formative frenzy when the galaxy was still assembling its arms. Fun fact, its spin. A leisurely 16-hour tumble, with brightness dips shrinking as the coma thickens, like a dancer cloaked in swirling skirts. No wild non-gravitational boosts here, unlike Oumuamua's eyebrow-raising acceleration, but plenty of asymmetric cyanide comas and dust fans that hint at uneven venting from a lumpy active core. This isn't random, it's a snapshot of survival, ejected young, frozen in time, now thawing to spill its secrets. What does it tell us? That interstellar wanderers aren't rare oddities. They're the norm, relics of violent births echoing across the cosmos. No interstellar guest would be complete without a parade of eagle-eyed observers, and 3I/A TLAS has drawn a stellar cast. Hubble's July images caught it 277 million miles out, streaking against star trails, nailing that nucleus size limit. Then JWST steps in, its infrared gaze piercing the coma to map those CO2 riches and icy whispers. Ground pounders like the Very Large Telescope snag polarimetric twists, high negative polarization signaling fresh, fluffy dust, and spectral lines screaming depleted carbon chains. No C2 or C3 fireworks here. But the showstopper? Mars' turn as cosmic paparazzi. On October 3rd, 2025, as 3I/A TLAS whipped by at 18.6 million miles, closer than we'd get, ESA's ExoMars Trace Gas Orbiter snapped a grainy gif of the fuzzy dot descending, coma aglow but no tail in sight thanks to the distance and dimness. Mars Express tried but struck out on the faintness. Even Perseverance's NavCam caught a streaky suspect on October 4th, though NASA's hush due to that pesky government shutdown leaves us hanging. NASA's fleet joins the fray. SphereX spies extended CO2 auras from mid-August, Swift ultraviolet hunts water vapor, and rovers like Curiosity peer skyward. ESA's JUICE, Jupiter-bound, gears up for a November peak with spectrometers and particle sniffers. It's a symphony of tech, from Earth's mountaintops to Martian orbits, all chasing this fleeting frame. Why the frenzy? Each snapshot peels back layers, gas production rates climbing, cyanide blooming asymmetrically like a one-sided flower, revealing how this outsider weathers our sun's heat versus its home turf. Stack 3I/ATLAS against its predecessors, and patterns pop like stars in a time-lapse. Oumuamua, elusive, rocky, no coma, just a reddish brick tumbling silently, sparking Avi Loeb's light-sail dreams before data grounded it in natural weirdness. Borisov, more comety, with familiar outgassing but a cyanide spike and organic hints. Enter 3I/ATLAS, bigger, bolder, CO2-drenched, with that defiant dust fan setting it apart. All three hail from hyperbolic highways, speeds unbound by our sun, Oumuamua at 26 kilometers per second excess, Borisov 32, this one a zippy 58. Yet they share a tale, ejections from young systems, where giant planets play gravitational pinball with icy planetesimals. Compare compositions. Our Kuiper Belt stuff is water-heavy. These extrasolar pops lean organic, reddish, depleted in volatiles, hinting at diverse nurseries. Implications? Huge. Each visitor tweaks models of planet formation. More CO2 means colder, farther out births. Backwards plumes reveal dust dynamics we can test in labs. And the big picture? The Vera C. Rubin Observatory might spot a 4I soon, turning trickle into flood. Future missions like Comet Interceptor could chase one down for a high-five flyby. This isn't just astronomy, it's genealogy, tracing the Milky Way's family tree through frozen messengers. What if these comets carry seeds of life or echoes of ancient oceans? The data's whispering, we're all connected in this galactic web. As 3I/ATLAS arcs toward perihelion and beyond, brushing Venus in November, Earth in December, Jupiter come March 2026, its story lingers like a comet's tail in our minds. We've unpacked a wanderer older than our sun, richer in frozen secrets than any local, challenging us with its quirks and confirming the universe's unruly blueprint. Key takeaways? Interstellar objects aren't flukes. They're the rule, hurtling clues about far-flung worlds. JWST's infrared revelations and Mars' distant glances remind us. Space exploration thrives on collaboration, from desert scopes to red planet robots. But here's the cosmic kicker. What if 3I/ATLAS's CO2 cloak hides microbes from another dawn, or its dust whispers recipes for planets like ours? Are we the outliers, or just one thread in an endless tapestry? Ponder that as it fades into the outer dark, outbound forever. If this sparked your stellar curiosity, hit like if you're Team Comet Chaser, comment your wildest theory on what kicked it our way, and subscribe for updates on JWST's next bombshell. Maybe that Europa ocean dive or Starship's Mars hop. Check my playlist on interstellar mysteries for more. The universe is calling. Watch the skies, friends. We're just getting started.